I will talk about plane waves in ducts, and I will especially talk about the impedance reflection factor and also the correlation between input impedance and output impedance and four-pole theory. So first of all, we have this conservation of mass is written like this density, static density times the divergence of velocity, particle velocity, plus the rho delta t is equal to 0 here. We also have Euler's equation of motion. The gradient of pressure is plus j omega rho times particle velocity is the same as 0. And the third one is adiabatic one is formulated here. And we have P, the static pressure is much bigger than the small disturbance for acoustics disturbance and so etc. And all those combinations gives us the wave equation, or maybe I should write it like this. Yes, and also use the notation for the pressure is equal to 0, and for harmonic signals it means that because a j omega t double derivative of this is same as minus omega n times a j omega t. We get the Helmholtz equation. Is equal to 0, harmonic signals. We use them over again. And then we have a duct with a terminating impedance. We call it ZAT, and we have a z-axis here at 0, and we have the incident pressure and the reflected pressure, the magnitude of this amplitude. And we assume that the cross-section error S, cross-section error S is much smaller than the wavelengths. So we are in the low frequency area. Okay, and the general solution to the Helmholtz equation will be a complex notation P plus times E j omega t minus k z plus P minus times E j omega t plus kz. We also need the particle velocity as a vector. This is minus j omega rho times delta p delta z here, and we use omega is k times z, so we get when easily that it is p plus rho c times ej omega t minus kz and minus minus p minus rho c times e j omega t plus kz. It's because of the differentiation. Yeah. And you can say we can have the reflection factor R is P minus divided by P plus, and then we get the we can write the pressure as P plus times A J omega T minus Kz plus R times E J omega T plus Kz. Oops. And the particle velocity vector yeah, here it is the Z part. So I use this notation here. It is P plus rho C times E J omega T minus Kz minus R divided E J omega T plus Kz. Yes. Then we have the specific impedance. Call it ZS. And Z is it's P plus divided by it is P hat divided by UC hat, and it gives us rho C times yeah E yeah. I will wait a minute. I will do it easier here. So we get CZ. Z is 0. Is P at 0 divided by UZ. Particle velocity 0. And it gives us yeah. And step we get the acoustic impedance at acoustic impedance at the terminating impedance at Z equal to 0 is the same as rho C divided by S times 1, because we put Z in equal to 1 here and omit this J, this harmonic terms, yeah, and yeah, and we get that R is the same as ZAT minus rho C divided by S and ZAT plus rho C divided by S. Here we can write this as rho C here E minus J Kz plus R EJKZ and E minus JKZ minus R EJKZ. Yeah. Oops. Okay. And we are interested now in what happens in the terminating input ZAI input impedance ZAI minus L. This is ZS minus L divided by S. This is rho C S times R, and we are calling it EJKL plus R times E minus JKL EJKL minus E minus JKL, and if you insert this R here, you get at the end, you get it is the same as ZAT times cosine KL plus sinus KL, no, plus J rho CS times sinus KL divided by J S rho C times sinus KL and plus cosine KL. Now we see here, if L is same as, we know that K is the same as 2 pi divided by the wavelength. If L is n times lambda half, we get that we get some KL is same as n times pi. That means that K cosinus KL is plus minus 1 and sinus KL is 0. So it means that we get that ZA input impedance is the same as output impedance, the terminating input impedance. Okay, but if L is the same as 2n plus 1 times lambda core, that means that we get that sinus KL is plus minus 1 and cosinus KL is 0. And that means that you get ZAI input. The sinus is, you get with rho C, those J's are deleted or cancelled, times 1 over ZAT. Yeah. So that means if ZAT is equal to 0, that means that ZAI is the same as J, rho C divided by S times tangents to KL, and in magnitude without this J. And if ZAT is infinity, it means that ZAI here, ZAI is 1 over J, isn't it? Yes, no, 1 over J with sinus infinity, 1 over J put onto KL. Yeah. Last thing I will say that is we have some QI input, PI, and output P0, Q0, and P0. Yes, we get that. We can write that P input, Q input, the volume velocity and pressure can be written as A, B, C, D times P, Q, and that means that P, I, for instance, A times P0 plus B times Q0. That means that A can be written as P divided by P0 with the condition that Q is equal to 0. And we can calculate different things. Yes, that's it. Thank you.